In this video, we're going to discuss the concentration of a solution. The concentration of a solution is equal to the amount of a solute divided by the amount of solvent or the amount of solution. This definition of concentration begs the question, what is the solute, what is the solvent, and what is the solution? Most often we think of the solute as being some powder that then we dissolve in a solvent, some liquid, to create a solution. So the example would be if you add a few tablespoons of sugar, that is the solute, to a gallon of water, that is the solvent, you would be making a sugar-water solution. While that's a fine working definition of solute and solvent and solution, the formal definitions are that the solute is the minority component of the solution, and the solvent is the majority component of the solution, and the solution is the mixture of all the solutes and the solvent. Now, if we go back to our sugar water example, our formal definitions of majority and minority component hold. The sugar, just being a few tablespoons, is in fact the minority component, and the water, as a solvent, is in fact the majority component. With these formal definitions of solute, solvent, and solution, we can start thinking about solutions that are different than simple salts or sugars dissolved into water. One interesting solution to think about is a gas phase solution, and an example is the atmosphere we're breathing right now. The atmosphere we're breathing is a mixture of multiple solutes in a solvent. The majority component of the atmosphere is nitrogen gas, about 78%. That is the solvent. The other solutes are things like oxygen, about 21%, argon, 0.9%, carbon dioxide, 0.04%, water vapor. All of these other gases are solutes in the solvent of nitrogen gas. Another example would be a solid-state solution, and that would be a chunk of brass. So brass is an alloy, a mixture of two different metals. Common brass, the solvent is copper. It's 63% copper. The solute is zinc. It's 37% zinc. Now that we have a formal definition for solution concentration, let's talk about some specific concentration units. The first one we're going to talk about is molarity. The symbol for molarity is a capital M. The definition of molarity is moles of solute per liter of solution. The units of molarity are moles per liter. The second concentration unit we'll talk about is molality. The symbol for molality is kind of this little fancy M, maybe an italicized M. The definition of molality is moles of solute per mass of solvent given in kilograms. The units of molality is moles per kilogram. The third concentration unit we'll introduce is called mole fraction, and the symbol for that is the Greek letter chi. There's usually a subscript to the chi to indicate which of the components of the solution the mole fraction is for. The definition of mole fraction is moles of compound A divided by the sum of all the moles in the solution, or total moles. The units of mole fraction would be moles divided by moles, or unitless, because the two moles cancel. The fourth and final concentration unit is percent by mass. The definition of percent by mass is the mass of the solute divided by the total mass of the solution multiplied by 100. The units of percent by mass would be grams divided by grams, so it is also unitless.